Hey, this is Donald Heslop, dual CCIE and owner and principal of Padlock Technologies, here to talk about Cisco Identity Services. This is going to be a brief overview of what it is, what it's used for, the use cases, where it sits at in the network, and why I believe every company should probably implement this in their network if they want to keep their network safe, at least at the network edge. So let's get into the conversation here. So first thing we're going to do is put our title, Cisco ISE. Now that stands for Identity Services Engine. So basically what this is there is a methodology called Network Access Control, or NAC for short. And this device or this appliance helps people actually do NAC, right? So where this basically sits at in the network is at the edge. Is an access switch technology here. Now there is a way to go above to the next layer, the distribution or and core layers or collapse core, depending on what your design is. But this is mainly a function at the access layer, right? So let's draw this out, and we're going to say, here's your access switches, right? And then let's say we have your distros, and this is going to be a distro stack. So these are two switches here. Switch one, switch two. And then we're going to draw a line between this because this is going to be your layer two, layer three demarcation. Now this is if you're doing your traditional. I'm not talking about Cisco defined access, or which is SDA, which basically removes span and tree from your entire campus network, but that's a whole different design. We're not even going to talk about that. So from an access switch, this is one, switch two, switch three. What happens is devices. So if you look at your network in thirds, you have users, computers, and then everything else, right? So we got users, computers, and then IoT, right? Everything else, if it's in that. So what Cisco ISE basically does is it gives you a way to authenticate and authorize these sections of things in your network to your network. So this is like the first line of defense, so to speak, right? Because if I don't know the user or the computer or the thing that is connecting to the network, I could technically just deny it. You can't get on my network unless I know who you are or what you are. A lot of people, a lot of enterprise networks try to implement ISE. I do a lot of assessments. I do a lot of rollouts myself. I can tell you right now, the majority of people do not know how to actually properly implement Cisco Secure ISE or any kind of NAC solution in their network. They kind of watch a video like mine's or a video from another creator, and they try to implement ISE, and it doesn't, or any other NAC solution, because ISE is not the only one, but that's the one we're talking about. And it's kind of like half baked, which causes a lot of security holes. But back to this. So we got a user that plugs in. We have, say, a printer. So a printer, we got a user, and we got another user here that plugs in. And let's say ICE sits over here somewhere. So we're just saying ICE sits over here. So what happens is when people plug in to your network, two things are going to happen. You're going to authenticate first, and then you're going to get authorized onto the network. Now, there's two ways you can do this. There is what they technically call these switches are NADs, or network access devices. And once somebody plugs into this port, there are two ways that you can technically get access to the network. One is called 802.1x. The other one is MAB, right? So MAB happens when you can't do 802.1x. So you can't do username and certificate, username and passwords. So UN and passwords, and then certificates. Obviously, certificates are the more secure way of doing things. I do not suggest anybody use username and password unless they absolutely have to. And with new versions of Windows, they have this thing called Credential Guard, which can definitely be a problem when you try to implement that with something like Cisco ISE. So mainly, and this is a design question, is it's do you care about the user or do you care that it's just a corporation managed machine? Most people go with the computers. We only care about if it's a computer and it's a managed machine by the organization. Now, if you're going to do this and you're using certs, you have AD, right? Or in your CA, pretty much are going to be involved in that. You can use something like Entra ID, right? And that's called a certificate connector, where you can push certs from Entra ID. That's going to tie into your NDED server, and this ties in on the NDED server on the back end, technically. Your CA NDED server, or you can use something like Skepman, right? Now, all this has to do with something called a trust chain, and that's a topic for another video, but we're really just going to talk about this ICE overview as a whole. But again, when people plug into the network, ICE is basically going to say, hey, I'm going to authorize you. If you don't match anything, I'm going to deny you. So it's implicit deny by default. And then I'm only going to let somebody in if I say they can get in. This prevents a lot of people from just coming in, especially if you get audited in your network. This is one of the tests that are bound to happen. They're going to go in, they're going to have a laptop, they're going to plug in and see if they get an IP address and see if they can get on the network. If they can, you will pop on an audit for that because you're not really controlling who gets access to the network. If one of these people that plug into your network, and we'll just use red, is your trusty bad guy, you are in trouble. All right? Because now, once I get access to your network, I can pretty much, do a scan. Now, there's other compensating controls that you should have in place. This is not ICE. Something like this is not going to be the end all be all. This is just, again, a edge technology to prevent people from getting on the network. You can do this thing called TrustTech or CTS, which you can now decouple IP address from authentication authorization. Like you could just decouple the IP from your policy, and then there's a SGT that will get applied to it, and then you can make your policies based on SGT. That's a whole nother conversation that we're going to get into once we start getting into some kind of design framework. This is just an overview. So, from a design standpoint, you have a couple deployments that you can, deploy when you're putting out ICE. So you have and it really depends on this thing called concurrent sessions. I always get that messed up. So what that means is how many consecutive or how many congruent sessions you're going to have hitting ICE at one time. For a 2-node cluster, 2 nodes, so you'll have your primary and secondary ICE node. If you have under 50,000, I believe, so under 50K, that's what you would do. When you get to between 50 and I believe 150,000, now you're looking at this thing. Now, this is really cheesy when I say this, but they used to call them ICE cubes. Cisco marketing at its best. And what that is basically your admin and monitoring node prime, admin and monitoring secondary, and then you have this thing called PSM. Now I'm going to go through this in the next board, what these roles are, right? All right. And then when you get anything greater than 150,000, you're looking at a large deployment, which breaks out of all these roles. So you'll have an admin 1, admin 2, monitor 1, monitor 2, and these are all secondary and primaries. And then you got a bunch of PSNs underneath it. I should just put P's. All right. Now, depending on where you sit at, you're going to be in one of those designs, right? Now, new vernacular with Cisco, they don't even call this ice cubes. They say it's a small, medium, or a large deployment. You're going to fit in one of those, right? Um, and it's all based on the sessions, right? If you're going to have, I would always say when you build this deployment to build for expansion, because if you start out, if you're like on the tip of 50,000, let's say you're at like 49, the likelihood of you going past 50,000 is probably greater than not. And doing a small deployment is not really good for you because then you're going to have to now redeploy this thing and maybe do a medium deployment or a large deployment depending on the sessions that you're getting, right? So you always try to at least go one bump above where you think you're going to be, right? Now, and that's where you think you're going to be. Like if you're teetering onto the next level, just go to the next level. If you're not, then just stay at the level you're at. So let's talk about the nodes that are in a nice deployment. So you got some very important nodes. Well, they're all important, but there's a couple that I always say those are most important, and then you can always add the additional ones, right? So they're all important, but here we go. So we got admin nodes. So I'm gonna say A. Admin node. This is where all the policy creation happens. All your policies are going to be created here. Right? Without this, you really can't do too much from a policy creation standpoint. And obviously, you'll have a primary, a secondary, and a cluster. There's no tertiary one. So it's always going to be primary and secondary. Same thing with the monitoring node. So the next one, I just told you, is the monitoring node. This node is in charge of all session information. Keeps all the session information. Now you need this session information because for certain things like COA, like posturing, rapid threat containment, all that kind of stuff, people need to know who owns sessions. So you go to this node to figure out who owns the session. Plus the live logs and all that comes from here as well for troubleshooting. Last but not, well, I will say the next one, I won't say last but not least because there is another one. It's PSNs, right? This is the policy service node. Or services node, depending on who you ask, right? This is the workhorse of the entire deployment. All right? Hopefully you guys don't hear my dogs in the background, but it is what it is. So all the requests, when someone actually plugs into your network, and remember I was telling you about like the radius and MAB and all that good stuff, all those requests go to this node. So this actually serves the request coming in. Right? This could be 2 requests. This could be radius requests. TACX, which is Cisco proprietary stuff for right now. Those will go to these nodes, and then these PSNs will actually they will download a copy of the policy from the admin nodes to their local node. So if they ever lose connection to this, it will still work. Like you will still function if you didn't have an admin node. Problem is you can't make any changes. That's why you usually have a primary and a secondary for fault tolerance, redundancy, whatever you want to call it. And then there is a PX grid node. Now this PX grid node, depending on who you ask, they usually sometimes combine these two together. But I don't usually do that because technically you would go into your deployment and you would see that you can select just PX grid as a function or a feature here. So what this is for what they call context information or contextual information, info sharing, right? And what that is the who, what, where, when, and how information, info on a particular section. Now, what this looks like, basically, I plug in the machine into the network. I use certificates. I authenticate. I have a session that's in the monitoring node. Now, let's say I have some integration. Now, I did a video on FTDs. Let's say I had some PX grade integration with FTDs. I would send that contextual information to the FTD, and then I could create a policy based on that. That's going to give me all my information I need. Case in point, when I was talking about TrustSec and the security group tags, if once I authenticate, I get a security group tag of 1,000. Well, when I send that security group tag to the FTD and say, 1,000, or this IP address here, I say 192.168. We'll just pull one out the hat. 10.1 has a SGT of 1,000. Well, when I create a rule that says SGT 1,000 to SGT 1001 is denied, doesn't matter the IP address anymore. It only matters about the SGT. As long as I know the IP to SGT mapping, I can create a rule based on that. If I was using something like, let's say, mitigate or order, which are for medical devices. So if you're in a hospital, this is probably something you should pay attention to. If you're trying to profile devices based on certain attributes, these pieces of software will help you do that. And then in ISE, I can create what they call a profile based on certain attributes and say, okay, based on these attributes that order sent me through PX grid integration, I know this is an EKG machine, right? And then I can create a rule that says if this is an EKG machine, they get on this VLAN and they get this SGT tag if you want to do VLAN, dynamic VLAN assignment. All right. So these are the personas, what they call them, that you can attach to an ISE node. And then from there, and I just had a quick brain fart here, but if you want to think about a cluster, let's look at it like this. So you'll have your admin, PNS, monitor, PNS, and then I'm going to put the PSNs in the front, right? PSNs in the front. I believe I already explained this, but just in case, let me drive this home. Now, these are going to be in one big cluster, but nobody really talks to these two nodes here. Nobody talks to that. We have our NADs out here. NAD 1. Now, I'm going to use NAD because this technically does not have to be a switch. This can be a firewall. This can be a router, as long as I can do radius on it. And then, again, computer, computer, computer. Now, the funny part about this design here is you don't have to be in the same geographical location. This can be your WAN between it. And then this can be build site 1 or branch 1, branch 2, and branch 3. Now, usually you're going to have some kind of tunneling mechanism. You could be DMVPN, it could be Flex VPN, it could be SD-WAN, and then those radius requests will be sent over your WAN topology, and they will be serviced by the PSNs. Now, the most important piece about this, if you do have a WAN infrastructure between sites and buildings, to get back to the PSNs. Now, depending on how far you are, you might have a PSN local. Let's say something here, and then they would just send their radius and TACX requests to that local one. But for replication purposes, 300 milliseconds. That's the target. 300 milliseconds or under, right? Because if you have anything from and this is called RTT, so round trip time, right? So if your RTT or round trip time is greater than 300 milliseconds, you can have some synchronization issues between the PSNs and the admin node and everything else in the cluster. So this is not something that you want to have a data center in California and then have a PSN in the middle of China somewhere, right? Because your round trip time may be very, very high, right? Unless you're doing something like Metro Ethernet, L2 VPN, something like that, where the round trip time doesn't look like it's like you're basically doing L2 through an MPLS through your service provider. You may be able to get away with that, but even then, I would probably have a separate cluster in that location, so you don't have to worry about this round trip time issue. So that was a brief description of ICE, what it is, what it's used for, certain design things that you need to look for. I'm going to create more of a series about this to start talking about certain topics. I think the next one I'm probably going to go into is just, the two methods of authenticating to the network, which is radius and MAB, and certificates versus username and password. But again, that's a whole nother video that I can go on maybe an hour on. I hope you enjoyed this video. I do a lot of assessments and deployments. If you're looking to implement this in your network, if you're looking to implement network access control, I'm going to put a link in here for you to do a discovery call with me so we can see where you are and where you want to go in terms of implementing Cisco ISE in your environment. Or if you already implemented Cisco ISE in your environment and it isn't working like you thought it was going to be, you may be a prime candidate for an assessment so we can see what's wrong with it and then fix it. I've seen a lot of, things that are not correct when people try to implement ICE, and I'm not saying it's your fault or anybody's fault. ICE can do a lot, right? Now, it can do a lot, but it doesn't mean it should do what you want, do all that other stuff. There's certain things in ICE that it should not do, right? There's certain things that it's great at, certain things that it's okay at, right? You shouldn't probably implement the it's okay things, right? But again, if you want to implement ICE in your environment, I'm going to leave a link in the description below. You can do a discovery call. It's not a sales call, again, because I don't know what's going on with your network right now. And if you've already implemented ICE in your network and it's not working like you thought it was, you are a prime candidate for an assessment. Click the link again, and during the discovery call, we'll find out, what's going on with your situation and see where we can help. Again, this is Donald, dual CCIE and owner of Padlock Technologies. Hope this video was informative. Thank you and have a nice day.